It's great to be here at OCP, speaking about Microsoft and our open source journey. Now let me get a feel for Microsoft's perception out here in this audience. How many people think of Microsoft as an open source company? I see a few hands. Well, what I'm going to do this morning is try to convince the rest of you that Microsoft really is an open source company. We embrace open source, and participating in OCP is a key part of our open source journey in working with the open source community and driving innovation into the ecosystems in which we play with open source. So I'm going to talk first a little bit about the ways that we view our interactions with open source. And when we sit back and take a look at all the ways we participate, it really boils down to 4 different distinct categories. The first one is enabling usage of open source with Microsoft technologies. And speaking as the CTO of Azure, this is one of the places where we really led the way largely at Microsoft with some of the ways that we help customers use their open source technologies of choice in our cloud. For example, when we launched infrastructure as a service a few years ago in Azure, the day we went out, we released both Linux and Windows distributions or operating systems for customers to run. So day one of Azure being able to host virtual machines, Linux was there. And more recently, we've announced a partnership with Red Hat that brings Red Hat onto the Microsoft Cloud with support from Red Hat, and a great collaboration that spans not just Azure, but a bunch of different areas, including .NET. When it comes to enablement, we go even further in Azure. We allow people to bring Puppet and Chef, for example, agents onto the cloud, and we work closely with those companies that are contributing code to that to make sure that their solutions work great in Azure. When we create our MapReduce as a service, we know that Hadoop has largely become the de facto standard for MapReduce platforms, and so we partnered with Hortonworks to build Hadoop as a service, MapReduce as a service on top of Azure. So those are just some of the examples of enabling customers to use open source in Microsoft. When it comes to integration, what we mean there is us using open source ourselves to build solutions for our customers. One great example there is our Azure Data Lake Analytics platform. This is part of our big data platform that we announced and released last year. Azure Data Lake Analytics allows you to perform deep computation across very large exabyte-sized data sets. And instead of building a brand new platform, computational data platform, to support that, what we did was use Yarn underneath the hood. And this is an example of us taking advantage of the innovation that's going on in the big data space on top of Yarn to build a service that we believe is differentiated and unique for big data. Releasing open source, there's been some very high-profile cases of us releasing open source in the last few years. One that I think stunned the world was our release of .NET Core as open source. And more recently, we released Visual Studio Code as completely open source. Those are just a couple of examples. TypeScript is another example of us contributing code out into the world that we develop internally at Microsoft, including code like .NET Core, which a lot of people consider to be state-of-the-art for garbage collected runtime systems. And finally, for contribution, this is our participation in the open source community at large. Really, this is what open source is about, is contributing code to open source, releasing code to open source, and when we release, we expect the ecosystem to work with us to drive innovation into open source. And the contributions we make here also are pretty broad. For example, Docker. We work very closely with Docker. And just in the last few days, John Howard, a developer on the Windows team, became a top 10 contributor to the Docker project with our work on that in the open source community. And I referred to HD Insight, Hortonworks. We're also a top contributor to the Hadoop project through our partnership with them. So it's not just us taking open source and using it and enabling it, but actually contributing back, which is really the spirit, true spirit of open source. This work in open source, so I've highlighted a lot of examples from Azure, but Microsoft's work with open source goes back 10 years when we originally started contributing to open source. And just this past week, we've got some examples of us in our continuing acceleration of collaboration with the open source community, with, for example, our announcement that we're taking SQL Server to Linux. And just a couple days ago, we announced we joined the Open Eclipse Foundation. So these are steps that just a few years ago, people would have probably considered unimaginable, and I'm guessing by the lack of show of hands at the beginning of when I asked my question, a lot of you might have also been highly skeptical we'd ever make moves like that. But we're here at Open Compute Platform Summit, And a couple of the steps that we've taken in the last few years involve Open Compute Platform. In 2014, we joined the Open Compute Platform, and shortly after, we made our first big contribution there, which was to take our server design, Open Cloud Server, and contribute that to OCP, and it was accepted. OCP, so Open Cloud Server, comes from us developing technologies internally, learning, and then sharing that out to the community, again, to help the whole ecosystem. To help the ecosystem, and also somewhat selfishly to help us, because if the ecosystem is driving innovation into the platform, we can come back and take advantage of it as well. The learnings that we've got here, I think, are pretty unique. We operate over 1 million servers, data centers all over the world. Azure's footprint itself, we operate in 22 regions. We've got 6 coming online this year, and of course, we've got many more that will be coming. And OCS, now, when it comes to us deploying new servers in our data centers, 90% of them are OCS servers. And we continue to deliver back innovations that we come up with and take innovations from the OCP community as we evolve our server designs. Now, I'm going to switch gears a little bit and talk about this networking stack in particular. If you take a look at the way networking looked 5 to 10 years ago, we had proprietary appliances that combined the management plane, the control plane, and the data plane all in a tight bundle of software that you really couldn't split open. And that made it a one solution kind of swallow for anybody that wanted to take advantage of networking technologies. As we started to build hyperscale clouds, this kind of approach simply doesn't work for scale and reliability. What we had to do was split these things apart. We had to take the management plane and create a REST API that could be accessed in a public way, in a multi-tenant way, for customers to on-demand request changes to the network topologies for their services and virtual machines that they were deploying. We had to take the controller and also break that out and make it a distributed controller to get the kind of scale and throughput that powers a hyperscale public cloud. And then finally, the switches themselves and the host, they had to become intelligent participants in the software-defined networking stack. They had to take commands from the controller that were the result of the REST APIs driving those topologies and driving those routes and firewall rules down into the switches and the host that were then effectively agents responsible for executing the will of the higher levels of the stack. So once we split this out, let's take a look at the host itself, because this is a place where there's also opportunities to split into layers that give up the ability for scale and innovation across different vendors and different solutions. And if we split that out now and magnify what the switch looks like, this is what it looked like at the beginning of last year, where at the bottom of the network switch, the ASICs, we had OCP hardware. Variety of different vendors, each delivering their own value in the hardware. OCP adopted Open Network Linux as the bare metal Linux distribution for powering switches, and ONI for deploying firmware updates to those switches. But what was missing at that point was a way to program those switches and a way to access the switch in a uniform way from above, from the controller, for example. So last year, Microsoft contributed the switch abstraction interface, SAI. Let me talk a little bit about what SAI is. If you take a look at the switch, the lower layers of the switch, of course, at the bottom you have a variety of different vendors, and I've got some of them listed up here that participated with us on bringing SAI to Open Compute Platform. Barefoot, Broadcom, Centec, Cavian, and Mellanox. And each one of those, in the past, spoke their own language, and today they still largely do. They've got their own APIs. Their own APIs for common things like quality of service and routing. They also have their own custom APIs, their own proprietary APIs that are value add for them. But what that meant was that anybody wanting to deliver some value add on top of a switch or create a switch on top of these types of ASICs had to come up with unique ways to talk to each of them. And the software stacks would be customized for these different ASICs. That makes it very hard to reuse technologies and proven production software across these different vendors, kind of limiting choice and the flexibility and the innovation at large that can happen when you've got a common plane. And so that's where software abstraction interface comes in, which is to create an abstracted API for all of the common functionality that you find in these switches. So layers on top can talk one language to all these switches, and then SAI with plugins from each vendor then translate that language into the ones that are specific to their own ASICs. And this has been really well received by the networking ecosystem and OCP participants to take advantage of this. It's giving customers choice, driving speed and agility. We found it very useful in Microsoft in our hyperscale cloud to be able to take advantage of the innovations coming from these different partners in a very uniform and easy way now that we've got a common software plane to talk to them. But what we're missing at this point still is the network software components that run on top of the software abstraction interface, of the switch abstraction interface. So when you have the switch, the controllers are talking to them again using custom protocols and interfaces to do things that actually end up programming the ASICs. And that still means that at some level, if everybody's writing their own network software components, that the APIs they're exposing are all different, and the software on top, the SDN software on top, has to be customized for each one. Again, limiting people's speed of innovation and choice because they've become very glued to a particular interface. It becomes hard to switch out and adopt something else that might have some innovation that you want to take advantage of. So I'm really excited to announce today Microsoft's next contribution to OCP, and that's something we call SONiC, Software for Open Networking in the Cloud. Now, this is clearly an acronym in search of some words that fit it. Unlike SAI, which is clearly an acronym where nobody had any imagination on words that would to fit it. But SONiC, Software for Open Networking in the Cloud, fills in that top-level box of the switch. It's in production already today at Microsoft, and we've worked closely with the partners that you see there listed on the left, Arista, Broadcom, Dell, and Mellanox, to bring this to OCP. All of them are working closely with us on supporting the SONiC network interfaces that create, again, just like SAI, an abstraction at the top level for the controllers to talk to. So what is SONiC specifically? It's a set of software components, runs on top of a Linux distribution, so that you add them on top of a base Linux distribution, and those software components do all of the common things that switch software would typically do, like store the routing tables. In fact, there's another example of us taking advantage of open source technologies for use inside of something that we're contributing. We use Redis cache in SONiC to store those routing tables. It also implements L2 and L3 protocols. It supports BGP programming. So all of the things that our software-defined networkings in our hyperscale cloud need to do are supported through interfaces provided by these software components. Link aggregation groups is another example. So the bottom line, what we hope to get out of this contribution is just like for SAI, of enabling flexibility and choice, which in turn speeds innovation, because you innovate in one place and it applies to all of the solutions, while yet still giving vendors the ability to deliver their own value. The same thing applies here. The vendors can still deliver their own value on top of SONiC. The common interfaces are all supported in a uniform way, so anybody wanting to talk to those, for the bulk of the network processing, takes advantage of the power of the open source ecosystem, which is part of Microsoft's overall journey and why we're so excited to be part now of the open source world. So this is yet another major step in Microsoft's open source journey. I can see it's been a busy week, SQL on Linux, the Open Eclipse Foundation, and now us contributing SONiC, the next step to OCP, with expectation that it'll be accepted by OCP. If you want to see SONiC in action or SAI in action, I recommend that you come and visit the Microsoft booth. You'll also see our OCS V2 hardware, which is also part of OCP, obviously, in action, so you can take a look at that.